Welcome students. Myself Dr. Anju Soni, lecturer chemistry from Jawaharlal Nehru Government Girls Senior Secondary Smart School Jawahar Nagar Ludhiana. I have come here to take you to virtual chemistry laboratory. Are you ready? Okay. You want to do practicals? Okay. Come with me. I miss my school. I miss my science lab. It might be in your mind. So its solution is virtual labs. This is an initiative of Ministry of Human Resource Development under National Mission on Education through ICT has given virtual laboratory, and this is the virtual lab you see here, view of virtual lab, which you can, where you can use your skills to do practicals just by having online internet connection. It's very simple, very easy. Virtual labs give so many advantages. Due to this COVID-19 situation, we have physical distance limit doing experiments. So it's very easy to do practical at your home, and we can, if sharing of costly equipment is not possible, even then we can do practicals at our place, and large number of quality labs we can have practical just on screen. Virtual science lab brings the world of science into the classroom and home. It's access chemistry labs on laptops or mobiles. It's very simple, very easy. You can do practical on your laptops or mobiles on your PCs. A virtual lab allows everyone to perform experiments. The drag and drop lab environment lets everyone to experiment with different reactions. This is one of the practical I have shown to you on this screen, and you see here that I'll perform it. This is volumetric analysis, and you will see how I do the practical very in the very simple way. Just watch it. I'm going to start it. Look here. I'll select either Mohr salt or oxalic acid. I'll select oxalic acid. And now drop rate 1, molality of titrate, it's M1, 2 molar, volume of titrate, it's V1, 10 ml. Now I start the practical, putting one test tube of H2SO4 in oxalic acid and heating it up to temperature of 60 to 70 degree. Now taking the titration flask for the titration, just dropping one drop at a time. Yes, now the color of the oxalic acid will change to light pink. That will be the end point. So keep on watching, have a vigil eye on it. Yes, it's light pink color. So this is the end point. Show the volume of titrant V2 by clicking it. Okay, now I started with Mohr salt, and just by changing the options. So you can also do in this way on your screen such type of practicals. Is it interesting? It's new thing for you? Okay. So let's go ahead. Come with me. Okay. This is preparation of inorganic compound. So in preparation of inorganic compound, we have ferrous ammonium sulfate, and you watch here, I'm going to start. I have ferrous ammonium sulfate, potash alum, and potassium trioxalato ferrate 3. So first of all, ferrous ammonium sulfate. I take the materials for preparing it: ferrous sulfate 7 gram, ammonium sulfate 3.5 gram. Because it's a dragging method, I have to drag it and put it into the beaker, and 3 ml of dilute sulfuric acid into it. Now pushing next button. This is hot water 20 ml into ferrous sulfate plus all the solutions mixed. Now stirring it with the stirrer. Now next step is by pouring it on the funnel. Next button, putting it into china dish, and burner is on. Heating it by stirring it constantly. Watch it carefully. Next step is putting this china dish into crystallizing dish, and this crystallizing dish is to be kept in cold water so that it's been covered first and then putting it into cold water so that crystals are formed. After some time, I am ready to get the crystals. Yeah. Next button. Next step is now decant off this mother liquor and adding ethyl alcohol to the precipitates. Again, decant it off. Putting this ferrous ammonium sulfate into on a filter paper, pressing it off by a filter paper so that extra moisture is absorbed and the crystals are ready. So beautiful crystals are ready. If you want to do next, you can do it. It's very simple. I am going to stop it here by just this preparation of ferrous ammonium sulfate. So you can practice further at your home. But how you can do it? Let me explain in coming slides. Next experiment is kinetic study on the reaction between potassium iodate and sodium sulfite. Again, its objective is to study the reaction rate of the reaction between potassium iodate and sodium sulfite using starch solution as indicator. The reaction between potassium iodate and sodium sulfite indirectly include the formation of iodide ions oxidized in acidic medium. The overall reaction takes place in 2 steps. The evolved iodine generates blue color with starch solution. This reaction is also called clock reaction. So, the faster the reaction, the shorter the time required for the blue color to appear. Adding dilute solution of potassium iodate decreases the concentration, that decreases the rate of reaction. Conversely, increasing the concentration of the reactant increases the rate of reactions. So this is the list of, along with their images, the materials required. So we need such materials to conduct practical, and it's available on online virtual lab. Let us start it.
Kinetic study on the reaction between potassium iodate and sodium sulfite. We require 0.01 molar potassium iodate in 4 different kinetic study on the reaction between potassium iodate and sodium sulfite. We require 0.01 molar potassium iodate in 4 different conical flasks, distilled water, measuring jars, 1 molar sulfuric acid, starch solution, 0.005 molar sodium sulfite solution, and stopwatch. Take 2, 4, 6 and 8 milliliters of 0.01 molar potassium iodate solution in 4 different conical flasks A, B, C and D respectively. Measure 10 milliliters of 1 molar sulfuric acid in a measuring jar. Pour it into the flask A. Repeat the same procedure for the remaining 3 flasks. Measure 88 milliliters of distilled water in a measuring jar. Pour it into flask A to make the volume of the solution 100 milliliters. Then measure 86 milliliters of distilled water in the measuring jar. Pour it into the flask B to make the volume of the solution 100 milliliters. Similarly, pour 84 and 82 milliliters of distilled water to the flasks C and D respectively to make the volume of the solution 100 milliliters. Measure 5 milliliters starch solution in a measuring jar. Pour it into flask A. Repeat the same procedure for the remaining 3 flasks. Take 10 milliliters, 0.005 molar sodium sulfite solution. Pour it into flask A. Start the stopwatch immediately. Watch the solution for the blue color to appear. Note the time when the blue color just appears. Repeat the experiment by adding 10 milliliters, 0.005 molar sodium sulfite to flasks B, C and D and record the time taken in each case for the solution to turn blue. Plot a graph between 1 by volume of potassium iodate against the time taken for the appearance of blue color by taking 1 by volume of potassium iodate along ordinate and time along the abscissa. It should be a straight line. From the graph, it is clear that the rate of reaction between potassium iodate and sodium sulfite increases with increase in concentration of potassium iodate.
So this is the graph they have shown in the video. So you can do it very easily on the screen. This is the observation and this is the plot of the graph. Is it clear? Conclusion is the rate of reaction increases with increase in concentration of potassium iodate. So Missing Your School Lab has one solution from the government, from the Ministry of Human Resource Development, that you use virtual labs. So this is the IT Minister launched O Labs as part of Digital India Good Governance Week in December 2015, and this is the view of labs. You can see here that at so many places in the higher institutes, IIT Bombay, IIT Delhi, COE Pune, IIT Hyderabad, all these are imparting online virtual lab facility for schools. You can see here Amrita University is giving facility to the school students, school teachers and schools for virtual labs. You can access their practicals. You can use virtual lab by getting yourself registered on Amrita O Labs, amrita.olabs.edu.in. And you can see physics, chemistry, biology labs from class 9 to 12, English and maths lesson for class 9 and 10th. And you will get interactive simulations, animations and lab videos. I have shown you simulation also. I performed practicals in front of you on simulations and animation also and lab videos also. So it's very interesting experience. You can see here PIB India has given that 1.12 million subscribers are using such type of facility presently. And this is the video I'm going to show you of the students of my school of 10 plus 2. The shot was taken in October 2018 when students were performing experiments on virtual lab and they were enjoying it a lot. Watch it. They are doing practicals in groups. Every group has taken separate practicals. They are watching videos side by side and some of them are doing animations, some of them are doing simulations and some are watching videos. And they are watching videos to make their concepts clear. This shot was taken from the screen of a student who was doing titration of oxalic acid. So you can also do it. It's very easy, very simple. This can be done just by doing registration. This is the page of their O Labs. You can register yourself here. Very simple. For the teachers here, for students here, for schools here. So if you register yourself, you will come here. How to register? You can read the page how to register by clicking here. You will come across this page and here to register you have to click here to register, and afterwards you will get this page by filling all the given blanks. All these blanks are filled and you can get yourself registered. By registering yourself, you will get this page of getting yourself login. You write your username, email ID and password. You can log in yourself for to access their facility. And next this page you will come across. This is physics, chemistry and biology. Practicals are shown here. You can do any of them. It's free of cost, no charges, only internet connection should be there. So this is your practical page of chemistry. So you can see so many practicals here. Next, you can select any of these practicals. If I select kinetic study on reaction between iodide ions and hydrogen peroxide, this is the theory. If you read the theory part, the concepts are more clear. You read it and you will also come across the theory part of the practical, as well as your so many doubts are going to be cleared. This is the kinetic study on reaction between iodide ions and hydrogen peroxide apparatus, the material required. This you can do only by clicking procedure button. Next is procedure, and you see here materials required is on your screen, and you also come across the animation. Animation gives you the real lab-like situation.
Preparation of inorganic compounds. Preparation of pure sample of ferrous ammonium sulfate. We require electronic balance, wire gauze, tripod stand, Bunsen burner, china dish, ferrous sulfate, ammonium sulfate, beakers, dilute sulfuric acid, ethyl alcohol, etc. Using the spatula, take a small amount of ferrous sulfate crystals. Place a
So I have shown you the animation of it. When you get yourself register, you can watch it. So now I am going to show you the simulator. How you can conduct practical on simulator. Just watch it. This is the paper chromatography practical. Look here and watch it carefully. I have blue ink, red ink and select the solvent from the isopropyl alcohol and water. I am going to start the practical. Watch it carefully. On the simulator I am going to start it. I take red ink and blue ink, isopropyl alcohol and water. This is the screen of it. So just by selecting red ink and blue ink, the capillary from this capillary I put a drop on this chromato Whatman filter paper and putting this Whatman filter paper in this box which contains isopropyl alcohol and water, and closing the box, wait for some time so that these spots of inks, both inks, separate from each other, and we will find the distance traveled by these ink spots. Now you can see both ink spots are separated. Opening the box, inference. Chromatography is the technique used separation of those solutes that dissolve in the same solvent. Now show scale. I'll find the distance traveled by both spots, both ink spots individually. Distance traveled by the solvent. It is 5. Distance traveled by blue ink 4.9. Distance traveled by red ink, I'm going to find it out. It is, I have to put the exact figure here. Only then the tick sign will appear. It is 4.4. RF value of blue ink. Now I'll find it out. What is the RF value of blue ink? It is 0.98, and RF value of red ink, this is 0.88. So again I can perform the same experiment by resetting it. How was it? So will you do it yourself? Okay, it's very interesting. I enjoy it. You will also enjoy it while doing. So this is the procedure of the simulator given side by side along with the actual lab procedure. Read it, watch it here. It's written that simulator procedure. You can select the mixture from this select the mixture drop down list. Simply students, it's drag method, drag and drop method. Okay. This is the procedure of simulator. I have shown you. Next is determination of EMF of a cell. This is again available on this OLAB video. Watch it.
determination of EMF of a cell. The device which produces electrical energy from a chemical reaction is called an electrochemical cell. The best example of an electrochemical cell is the Daniell cell, in which copper and zinc electrodes are immersed in a solution of copper sulfate and zinc sulfate respectively. The two half cells are connected through a salt bridge, which is an inverted U-tube filled with a saturated solution of an inert electrolyte containing agar-agar. Here, zinc acts as anode and copper acts as a cathode. At the anode, zinc undergoes oxidation to form zinc ions, which pass into the solution and electrons. If the two electrodes are connected using an external wire, the electrons produced by the oxidation of zinc travel through the wire and enter into the copper cathode, where they reduce the copper ions present in the solution and form copper atom, which are deposited at the cathode. The potential difference between the two electrodes is called cell potential or EMF of the cell. It is measured in volts. Our aim here is to study the variation of EMF in the zinc-copper electrochemical cell with the change in concentration of electrolytes at room temperature. Materials required: zinc sulfate solution, copper sulfate solution, zinc rod, copper rod, digital voltmeter, salt bridge and connecting wires. Procedure: take 1 molar copper sulfate solution in a clean beaker and 1 molar zinc sulfate solution in another beaker. Take a clean copper rod and dip it into the beaker containing 1 molar copper sulfate solution. Similarly, take a clean zinc rod and then dip it into another beaker containing 1 molar zinc sulfate solution. Take the salt bridge and connect the two solutions through the salt bridge. Now, take one connecting wire and using the wire, connect the copper rod with the positive terminal of the digital voltmeter. Copper electrode acts as the cathode. Similarly, take the other connecting wire and connect zinc rod with the negative terminal of the voltmeter. Using the wire, zinc electrode acts as the anode. Now switch on the voltmeter. Note down the voltmeter reading. This value gives the EMF of the cell.
So, at the end, you will come across Viva questions of every practical. You attempt these questions and you can assess yourself, you can evaluate yourself. Okay, students? So, you first for that you have to sign in, you have to log in. So, get yourself registered so that you can have free access to this virtual O Labs. These are 15 topics. Go for it and make your concepts clear. Thank you very much, students. Work hard, stay safe, stay healthy. Thank you.